All right. Good afternoon, everybody. Thanks for joining us today. I know some folks are still getting logged on here, but I do see it's 1 o'clock, so we are going to get rocking and rolling here. Today is our second webinar in our month of lubrication, Lubruary, as we so fondly call it. And we're excited to have James Kordsmeier and Adrian Messer talking about practitioners' journey to improved lubrication practices. Should be a really good session. Got some good kind of real life examples of how they've been able to see some improved results at the facility down there in Georgia, right? With what they've been doing with their lubrication. So they're going to be tag teaming it today. Just a couple housekeeping things before I turn it over to James and Adrian. I am recording this, so if you have to hop off early or if you've got some colleagues who couldn't make it, we'll have this available on our website along with all of our other webinars that we've been doing, so you can check that out. We do welcome questions, so we try to keep this as interactive as we can, knowing that we're all kind of spread out around the globe. But feel free to type those in. I'll keep an eye on those, and I'll get those asked over to the guys as it makes sense. And of course, we'll have some Q&A time at the end as well. So feel free to ask anything that might come up. And, just one last note, we are doing this live, so if we have any technical issues, sometimes the audio can get funny or if someone loses their internet or something, we'll get it resolved as quickly as we can, but just want to point that out. That's one of the risks we take doing these things live. But anyhow, with that, I am going to turn the screen over to Adrian and let this thing get going.
All right, perfect. Well, let me just get a transition over here, and hopefully everyone can see that. Maureen, are we good?
Yes.
All right, perfect. All right. You being here today to be a part of our second webinar in our lubrication series for the month of February. And today we're going to kind of bring two perspectives. We have James Kordsmeier with CMEX, who will give you a practitioner's view. And then what's amazing to me on the ultrasound side is just how big of an application condition-based lubrication of bearings has become for ultrasound. So hopefully today we'll give you some good takeaways, whether you're currently using ultrasound in your lubrication practices or if you're looking to implement ultrasound for condition-based lubrication of your bearings and rotating equipment. Hopefully we'll give you some good information today to take back with you. Again, for myself, I've been with UE Systems for a little over 13 years, so it's really become a passion of mine to go into plants, facilities, and really evaluate and help them out with their ultrasound program. I did go to Clemson University, so it's a great year to be a Clemson Tiger, so go Tigers. I am a CMRP. I know UE Systems as a company, we really value encouraging really all of our associates to be involved on the local and the national level for the SMRP, and in turn also encourage them to get that CMRP certification. We feel like there's a lot of value to be in that category or to have that certification. So therefore, I'm locally involved in the Carolinas chapter. I'm currently the chairman of the Carolinas chapter. I live right outside of Greenville, South Carolina, so we're really trying to get the chapter active and have some events planned for the future. And I'm also involved on the national level as the chair of the Member Services Committee with SMRP. So now I will let James introduce himself and we'll get started.
Thank you, Adrian. And I agree, it definitely is a good time to be a Clemson Tiger. Congratulations.
Thank you.
My name is James Kordsmeier, for all of you that are out there. I'm a reliability engineer with CMEX. I've been with the company here in Georgia almost 3 years now. I'm a graduate of Louisiana Tech University. CMRP for a little over a year now. I am ultrasound level 1 trained, certified through GE, and then I have a vibration analyst category level 2 training through Emerson. So got a little bit of experience with ultrasound, and always looking to further my experience with that. And so next slide, I'll show you kind of what we're dealing with. Here in Clinchfield, Georgia, we're in the middle of Georgia. Outlined there is in the red is our property lines. If you look down in the lower left, that is our quarry property down there. Then we have conveyors and crushers that bring our rock over to the north side of the road. Up in the top right corner, that little bitty piece, that's the plant, and that is actually where we create our Portland cement. We do 3 different types there. We are one of 11 plants in operation in the U.S. Of CMEX, but we actually just sold 2 of them, so now we're down to 9 plants for CMEX in the U.S. The Clinchfield plant here in Georgia was originally built for $2 million, which is a portion of what we spend on our annual outage these days. So it's, everything's getting more and more expensive. We started as Clinchfield Portland Cement, then we became Penn-Dixie Cement Corporation, then Medusa, Southdown, and finally CMEX in the year 2000. We started in 1925, though. We operate with 1 quarry, 1 raw mill, which is a vertical roller mill. We have 1 kiln. It's a FLS Policius design. And we have 3 finish mills that are all ball mills. Our capacity for this specific plant is around 900,000 tons per year. Thank you, Adrian, for the next slide. So here at this plant, we have 1 reliability engineer up until October last year, and we hired a second one. We still have 1 reliability technician, 1 lubrication technician, and that's kind of our reliability group. And then we have 13 mechanics. That 2 coordinators just went up to 3 coordinators, 1 planner. We have 8 electricians, 1 coordinator/planner. And all of those people get to work on 107 critical pieces of equipment that have oil analysis. And of those 107, we have other auxiliary equipment, including those 107 that need lubrication. So we have approximately 538 lubrication components. And that's for the plant side only. That's not including everything that, the crushers and everything that leads up to the plant side. So we have our work cut out for us as far as lubrication goes. A lot of oil-filled systems, gearboxes, but mainly we have a lot of bearings that need lubrication. And so with that, I'll turn it over to Adrian, and he'll take you through kind of the importance and what is ultrasound lubrication, and then we'll wrap up with me, and I'll tell you about kind of where we have journeyed from and to, and where we're wanting to go next.
All right, thanks, James. Yeah, so one of the fun things about my job and what we do at UE Systems is we're in different plants and facilities on a weekly basis. And in looking at how people lubricate their equipment, most of the time that we see it is a time-based lubrication PM. So again, a PM is generated that says to go to a particular piece of equipment and apply X number of pumps of grease. So whether that be every month, every so many hours, every other month, every week, that's what people do. So again, traditional lubrication programs are time-based, to where those PMs the equipment is lubricated at that timed interval, regardless of whether it needs grease or not. So the issue, that being the main issue with time-based lubrication, is what if that piece of equipment doesn't even need grease? What if it doesn't even need to be lubricated? And what if the frequency, so how often that piece of equipment is being greased, is too often? Or what if the bearing is in a failure mode that is beyond a lack of lubrication? So the bearing is more severely damaged rather than just being in a lack of lubrication condition. So just by nature, the inherent risk for time-based lubrication is to over-lubricate. Again, we're going out and we're greasing that piece of equipment based solely off of what that time-based PM says to do. So all we're doing with ultrasound is we're using ultrasound to listen to the equipment while we're greasing and then watching the associated decibel level. And we'll talk about that. I have some screenshots from our Spectral Laser software that show bearings in the process of being lubricated, what you would expect to see, especially if you're using the UltraProbe 15,000 that has the onboard spectrum analysis. You can actually see that in real time while you're applying grease. Or if you're using, say, just simply the UltraProbe 401, the digital grease caddy, you're watching the decibel level as you're applying that grease. So, and we'll talk about 3 different scenarios. We've just simply called it a good, better, and best scenario on how you can improve bearing lubrication through using ultrasound. For those of you that aren't familiar with the technology, who maybe aren't currently using ultrasound, or maybe it's something that you've heard about that you're not currently using, we're simply a listening device. We're listening for high-frequency sound that is above the range of normal human hearing. The lowest frequency that we can tune or set the instrument to is around 20 kilohertz. If you have more of an entry-level instrument, most of those entry-level instruments are on a fixed frequency. But really, if you want to get into trending and diagnostics of ultrasound, to where you're setting baselines, you're setting alarm levels, you're recording sound files, we really recommend at a minimum that you have an instrument that has frequency tuning. But even still, the lowest frequency that we can tune or set the instrument to is still above what we're capable of hearing as humans. On the average, the upper threshold of what humans are capable of hearing is around 16 to 17 kilohertz. Well, if the lowest frequency that we can tune or set the instrument to is 20 kilohertz, it's already listening for sound that is above what we're capable of hearing. So in most cases, we don't have to be too concerned about ambient background noise because, again, we're listening for sound that is above what we're capable of hearing. And since the ultrasound instrument is only listening for the high-frequency sound that is above what we're able to hear as humans, it makes it very easy to locate and pinpoint the sources of problems. It makes it very directional, so we can easily pinpoint which bearing is bad, or we can easily locate where the compressed air leak is, or where the electrical discharge is. So when we're using ultrasound to lubricate our bearings, we're actually listening to the quality of the bearing. So a bearing that is in a failure mode that is beyond a lack of lubrication more than likely will sound different than a bearing that is in just need of lubrication. The source of the ultrasound when a bearing is in a lack of lubrication condition is friction. So once it is to the point where it needs grease, there's just a simple uniform increase in friction, which also produces more noise. So a bearing that is in need of lubrication will have a much higher decibel level than one that is properly lubricated or in a good condition. But you have to think, if we're going out with just a grease gun and we're not listening to the bearing while we're applying that grease, again, the lubricator won't know if the bearing even needs grease. Again, they're just going out with a grease gun to apply grease without actually listening, or better yet, they're not getting a decibel level of that bearing, something that they can then trend and then determine if that bearing even needs grease or not. So we're going to find more problems through using ultrasound for condition-based lubrication than just traditional means of bearing lubrication. Again, someone just going out with a grease gun. Now, things that you can do to be successful, as with any PDM technology, you always want to make sure that you plan for success. So hopefully you have a good asset catalog of the assets that you want to monitor. And then once you have a good database of those assets, hopefully you've gone through some sort of asset criticality ranking to then determine what assets are the most critical to the process. And usually that is a good place to start applying PDM. It's been said that if you're not currently doing any PDM or predictive maintenance or condition monitoring on any of your assets, once you've gone through that ranking, start with the top 20% or the most critical assets, the top 20%, And then once you have those assets, once you know what's critical, then apply the technology that will find the failure modes that you're looking for, whether that be ultrasound, whether it be vibration, or an infrared. Apply the PDM tool that will find that failure mode at its earliest instance. Now, where ultrasound tends to be very good, and probably as we go through this presentation, you'll realize that there are a lot of overlaps between ultrasound and vibration analysis. Again, it just depends on what the failure mode is that you're looking for. Ultrasound tends to be very good at determining when bearings need to be lubricated. We're also very good at finding early stage premature type bearing failures. We're very good at finding these early stage bearing failures. But if the failure mode that you're looking for is misalignment, then ultrasound is not the right tool for that, where vibration analysis is very good at that. So again, just understanding your assets, understanding the failure modes, and that will help you to determine what technology will that you can apply that will find that failure mode at its earliest instance. We'll talk about setting up routes. For those of you that are currently using ultrasound, you can download the most current up-to-date version of our UltraTrend DMS software right from our website. And when we talk about the best scenario, we'll talk about setting routes, establishing baselines, and establishing alarm levels. Along with that data, really a best practice would be to record the sound file as well. So that way we have not only the baseline dB, but we also have the baseline sound file, what it should sound like. We can then later, at a later date, once it reaches an alarm level, we can then overlay and compare the baseline sound file to the current alarm level sound file. Now, in setting up your routes, these are the recommended alarm levels. We've had these numbers for years. We've reconfirmed these just from getting feedback from our users. A more recent study that was done by Dr. James Neal from the University of Waikato. That information was presented at our Ultrasound World Conference a few years ago. So, these are the recommended alarm levels. So regardless of what your baseline is, if you have an 8 dB increase above that baseline, that represents now the point to where the bearing is in need of lubrication. So your low alarm or your lack of lubrication alarm is going to be 8 dB above the baseline. And then at 16 dB above the baseline, now again we have now where the bearing is in a failure mode that is beyond a lack of lubrication. And then at 35 dB and up, that's the third level that is recommended. Certainly at this point, if you're familiar with the P to F curve, we're much closer now to point F or functional failure, to where that piece of equipment can no longer run the way that it was designed and installed for. Certainly at this level, we would be able to hear it audibly without the aid of ultrasound. The only time that we would really recommend that you adjust these alarm levels, well, there's actually two cases. One on slow speed equipment. What we feel like is extreme slow speed would be anything below 100 RPM. So obviously a bearing that's moving that slow is not going to produce as much high frequency sound as a bearing that's turning at, say, 1500 or 1800 RPM. So depending on what that initial trend is showing you on your data collection will determine where you would need to set your alarm levels. But certainly on the slower speed equipment, you may want to look at lowering these alarms to where instead of using 8 and 16, maybe you're using 4 dB and 8 dB. Also, equipment that is on a VFD, what we found over the years at looking at equipment that's on a VFD, and the research has shown that narrow deviations in the RPM or small changes in speed have little to no effect on the decibel level. But again, if you are seeing slight changes in the decibel level according to what the speed is, you may want to look at widening these alarm levels. So again, instead of using 8 and 16, maybe you use 10 and 18. Again, it just depends on what that initial trend is showing you. But again, if you are seeing changes in the decibel level according to what the speed is, then you may want to look at just widening those alarm levels. But most of the time, we find that our end users out in the field, these are the numbers that they're using. Again, the low alarm set at 8 dB above, and then the high alarm set at 16 dB and above. So once you've set up your route, once you've begun to collect data, you can then set any baseline that you want. The software defaults to the first reading that you take and download it back into that route or back into the software. It's going to set that as the baseline, but you can change that baseline at any time. So once that baseline is set, we can set the low alarm or the lack of lubrication alarm, and then we can set the high level alarm. So then your decibel level readings are collected, and then instead of going out and greasing everything like you normally would on a time-based lube route, then we only grease the points that are currently flagged or currently in that low alarm condition. Again, that low alarm condition is going to be the lack of lubrication point. So again, we're greasing only the points that need to be lubricated instead of greasing everything as you would on a time-based interval. So then we would simply apply grease until that decibel level comes back down to the baseline, and then we're going to stop greasing. Again, the source of the ultrasound is friction. So when a bearing is in need of lubrication, there's an increase in friction, therefore an increase in noise. And then we're going to watch that decibel level as we're applying grease. So as the grease enters that bearing housing, there's less friction, therefore less noise, and then eventually it will drop back down to a more normal level. And that's exactly what you can expect to see. So again, the three things that you can expect to see while we're greasing bearings using ultrasound: if the bearing needs grease, the decibel level will fall as lubricant is applied, eventually back down to a more normal, steady level or the baseline level. If the bearing is already sufficiently lubricated, so let's say we go out to grease a bearing and that bearing doesn't even need grease. Typically what we'll see there is, once we walk up and make contact, we get our decibel level reading. Usually just after a couple of pumps of grease, the decibel level will slowly start to increase. So if we're watching the decibel level and the decibel level starts to rise as we're applying grease, that's going to give us an indication to stop, because we've reached the threshold now to where we've started to over lubricate the bearing. And we don't want to pump any more grease into that bearing than we have to. And then the third scenario is, let's say we're out there greasing a bearing, we're watching the decibel level, and we're applying grease, we're pumping grease, but there's no change in the decibel level. Usually we see that it's one of two things. One, if the bearing has some sort of damage, and if that bearing is in a failure mode that is beyond a lack of lubrication, then there will be little to no change in the decibel level. Lubrication is not the solution for that bearing. In other words, it has damage. It needs to be changed out. Or it's very common to see this as well. So if that bearing has already been previously over lubricated, and if that seal has been busted through that due to over lubrication, then all of that grease that we're pumping into that bearing housing is just going out into areas of that equipment where it shouldn't be going. Again, if the seal is busted and we're applying grease, that grease is not staying inside the housing. So that's where you start to see grease entering into the windings of the motor, and again, areas where it shouldn't be. And therefore, you would see little to no change in the decibel level. Now, if you've gone out to grease a piece of equipment that it has reached that low alarm level and you applied grease until it fell back down to the baseline, for more critical assets, a follow-up reading should be taken to ensure that the decibel level did not rise again after lubrication. You could even use a complementary technology, say vibration analysis, to even confirm that greasing that bearing, that there were no additional failure modes present that would be hidden by the lubrication. And again, you can't do this for all of your assets, but certainly some of the more critical assets, you'd want to do a follow-up reading. So if you weren't scheduled to take another reading on that piece of equipment, say for another month, then it may be a good practice to go out, say 1 to 2 weeks after greasing the equipment, to make sure that that decibel level did not come back that quickly. If the decibel level came back to where it was prior to lubrication that quickly, then it could be a sign that there may be another failure mode present, again, that lubrication wasn't the solution for. And when we see people start to implement ultrasound into their time-based lubrication PMs, we start to see people adjusting those lubrication PMs based off of what ultrasound tells them. So typically we see that the amount of grease that was called for on that lubrication PM, most of the time is too much. So they're basing it solely off of the bearing manufacturer's recommendations or the motor manufacturer's recommendations, and typically we see that those recommendations tend to err a little on the over lubrication side. So not only do we see people adjusting their lubrication PMs based off of how much grease they're using, but also the frequency, so how often that piece of equipment is being lubricated. So if they're greasing it once a month prior to using ultrasound, again, ultrasound will tell you exactly when it needs to be lubricated. So sometimes we see that adjusted to where it's every other month or every 6, every 8 weeks. So again, ultrasound can tell you a lot to help you to further adjust and make more effective lubrication PMs. Now, the two instruments that we have that are used solely for condition-based lubrication, we have the UltraProbe 201 Grease Caddy. This instrument's been around for several years. It's probably the easiest instrument that we have to use, but you can see it's just a simply this person here that's using it has it mounted on a little belt clip holster. You can also attach it directly to the grease gun. There's a magnetic mount contact probe that you want to make contact with the closest point to the bearing. Again, by nature, high frequency sound is very low energy, so it tends not to travel very far from the source. We want to get as close to that bearing as possible when we're listening to it with ultrasound. The readout on it is just a simple vertical LED bar graph that lubricator is going to look at. We're hoping to see those light bars decreasing as we're applying grease. If those LEDs start to go up, that means there's more noise. So again, when we see the LEDs going up, we know to stop. Again, we're hoping to see a drop or a decrease in those LEDs as we're applying grease, eventually back down to a more normal or steady level. It is important to always wear your headset while you're listening to the bearing. Again, it's very important to listen to the bearing as well as watch the decibel level while we're applying grease. And then more recently, we have the UltraProbe 401 Digital Grease Caddy. We had a lot of feedback from the people who were using ultrasound for bearing lubrication that they really wanted to integrate data storage and some other pieces of data that they could store. So this particular instrument here does have the data storage, so it will work with the UltraTrend DMS software that allows you to set up routes, it allows you to set baselines, it allows you to do trending. So we can set the low alarm or the lack of lubrication alarm. We can set the high alarm. Also, part of the data that it stores is we can actually input in the number of pumps of grease that we applied. And that's where we can start to trend and track now how much grease we're using. We can also build in, when we build the route, we can build in the planned number of pumps of grease. So just as an example, let's say we come to a piece of equipment and the planned number of pumps of grease was 10 pumps. But after using ultrasound, let's say after 5 pumps of grease, the decibel level falls back to the baseline or back down to a more normal level. Well, there's no reason then to pump 5 more pumps of grease into that bearing. At that point, you're only going to over-lubricate it. So part of the data that we can store is we can input in that we only put 5 pumps of grease. So again, in the UltraTrend DMS software, that's where we can start to track and trend the actual number of pumps of grease compared to what was planned. Some additional information in the DMS software is we can input the number or the cost of the grease. So if we know how much that tube of grease is costing, not only do we know mass-wise how much grease we're using, but we also know dollar-wise how much grease we're using. And there's also a lubrication route report that you can generate with the UltraProbe 401 that once we download all the data back from our route that we've collected, we can then download that back into the DMS software and then generate a report that will give me everything that's currently in that low alarm level. And again, instead of going out and greasing everything like we normally would on a time-based lube route, then we're only greasing the points that are currently in that low alarm condition. So there are some really nice application-specific reports that you can generate using using that DMS software. Now, I mentioned earlier that we have basically 3 scenarios on how you can improve lubrication practices, and we've simply called it good, better, and best. So the good scenario would be to lubricate the equipment according to the manufacturer's recommendations. You'd want to consult with your lubricant supplier to ensure that the correct grease is being used for the right application. And then to take it a step further, determine the lubrication frequency and the amount based off of the equipment runtime, operating conditions, and the bearing dimensions. So that's a good scenario. It's certainly a lot better than just going out with a grease gun and applying so many pumps of grease. So many times we see in facilities, when you ask them, well, where did you determine the number of pumps of grease? Well, the person previous to me, they always put 10 pumps, so I figured 10 pumps is what it needs. So you'd be surprised at what you see when you go out into some of these plants and facilities. I mean, as important as lubrication is to rotating equipment, the practices or the methods that are used to determine how much grease and then even the right grease tend to be can be greatly improved. So then a better scenario. So if time-based lubrication methods are your only option, so if you want to continue on the time-based lubrication PMs, at least implement an ultrasound instrument, a grease caddy, even just as simple as the UltraProbe 201, to lubricate with that PM. So if the lubricator goes out with that PM and they're using the grease caddy, again, just like what I gave you before, so if the PM calls for 10 pumps, but if that decibel level falls after 5 pumps or 6 pumps, then there's no reason to put any more grease in there than we need to. So at that point, we would stop. And then through that implementation, through over time, that's where you can start to adjust those lubrication PMs based off of the frequency and the amount of grease of what ultrasound has told you. So at a minimum, this will let the lubricator know when to stop applying grease. And then also other problems will be found. Again, if you make contact with that bearing, a bearing that has physical damage to it will sound a lot different, as well as have a higher decibel level than a bearing that's just in a lack of lubrication condition. And then finally, the best scenario kind of incorporates what I've talked about earlier with setting up routes and then setting baselines and then recording that baseline sound file. Again, we're trying to gather as much information as we can to make a good diagnosis of the health of that asset, something that we can base that off of and then something that we can trend. And where ultrasound is as a technology, that's really where we are today. It's not just about listening, it's not just about the decibel level, but it's really making use of those recorded sound files. Because now where ultrasound is as a technology, we're really getting into more of the diagnostic side of ultrasound. For those of you that have the latest version of our Spectral Laser software, we've actually integrated in a bearing fault frequency calculator to where if we know just a couple of pieces of information, like the speed and the number of balls or the number of bearings, it will calculate out an outer race, inner race, ball pass, and a cage frequency. So again, we're getting into more of the diagnostic side of ultrasound. So we use an instrument that has data storage. We're establishing baselines, setting a low alarm or lack of lubrication alarm, and then a high alarm. And through that data collection, we're trending that decibel level over time, and then we're only greasing the points that are currently in the low alarm condition. And then we're going to apply grease until the decibel level falls back down to the baseline, and then we're going to stop greasing. For more critical assets, I would want to do some sort of follow-up inspection prior to the next scheduled data collection to ensure that the decibel level remained lower or had not risen back to where it was prior to lubrication. It would also be a good practice to record a new sound file once it has reached an alarm level, so then we can compare the current alarm level sound file to the baseline sound file. Now, these are two screenshots from the UE Spectral Laser software. The picture here at the top, if you look here at the left, you can see that we have a very high amplitude, very high decibel level. As grease was added, gradually that decibel level fell back down to a more normal level, and then we stopped greasing. So again, on the left is before lubrication, on the right is after lubrication. The picture at the bottom shows what happens when you start to over-lubricate a bearing. So this bearing here was lubricated based off of a timed PM. So this person lubricated the bearing based off of what that PM called for. So again, starting at the left, you can see a very high amplitude. Gradually, as grease was added, the decibel level fell, and that's really the point to where they should have stopped. But if you continue looking at this time waveform, you can see that gradually, as more grease was added, the amplitude or the decibel level increased really back to what it was prior to lubrication. Indicating that, again, as we apply too much grease, there's an increase in friction, therefore an increase in noise. So if we start to see that decibel level increasing while we're applying grease, we would definitely want to stop because we have reached the threshold where we have started to apply too much grease. Now, I believe these two sound files are on our website. They're in the sound recording library. So again, they're bearings in the process of being lubricated. And if you're using the UltraProbe 15,000, which has the onboard spectrum analysis, you can see the FFT or the time waveform in real time while you're collecting the data, so you would be able to see this exact same thing right on board the instrument. But if you want to hear those sound files, they're on the website under the sound recording library. If you want me to email those sound files to you, drop me an email and I'll be glad to share those with you. Okay, James, I'll let you take it from here and kind of talk about what you're doing currently at CMEX, and we'll wrap it up and have time for some questions.
Adrian, thank you very much for introducing us to ultrasound lubrication. It's been great. So to get back to Clinchfield, CMEX, you know, I talked about how big we are, how many different points of lubrication we need to do every month or every week. So what we did is, I believe it was last January, I began this journey with UE Systems. I actually purchased one of the UltraProbe 201 grease caddies. And like Adrian said, it's the easiest one to use. It's just got the LED bars on the front, you know, with the headphones and everything to be able to use it. So started with my lubricators. And so for quick wins, we got in there, got to start using it on our cooler fans for our clinker cooler, and then basically focused on our higher RPM equipment, the things that are most critical, some of our most critical bearings, basically things that were 1,800 RPM up to 3,600 RPM. So it ended up being around 40 to 50 lube points that we started with, and it turned out real well. And if you think back to the pictures you just saw of what it looks like when you're lubricating a bearing, you know, we had a lot of success stories as far as, you know, we used it and it lubricated and then it was satisfied and we went from there. But then we had a couple of stumbling blocks where we over lubricated even while using our grease caddy. Kind of a learning curve is what I attributed it to with our lubricator. You know, where it cost us a little bit of money, we had to take down and replace a bearing, get it back going. But all the other wins, I would say, is worth it. Our short-term plan, so install access for ultrasound equipment. What I'm talking about here is, you know, a lot of the guarding, you know, we are a mining facility, and so a lot of our guarding, they just have done overkill because industry comes in here, they inspect something, they say, hey, that thing's not guarded, and so they don't make a specific guard just to go around that, so they just basically guard off the entire area. So what we're doing is going around. I've had some issues with trying to modify and make some smaller guarding so I can actually access the bearings and the equipment easier. But sometimes guarding issues are still a stumbling block for us, and I think, Adrian, you've got some stuff that you want to talk about in a few minutes about some remote monitoring. So we'll let you talk about that in a few minutes. But that's kind of been some issues with us as far as guarding goes. You know, we've done some removal of some lube blocks, basically where we've run extra line so that the lubricator doesn't have to go right there next to the equipment. And so we've removed those so that they get right up on the equipment. They put the probe on there, and they're able to listen to the bearing as they lubricate it. And then short-term plan, you know, currently we have a route, a greasing route. It comes out weekly, and we go to each one of those 538 points or a portion of those 538 points and lubricate it. And I want to initiate an ultrasound route where they utilize the ultrasound on the majority of those instead of just what we talked about earlier, you know, my cooler fans, my higher RPM equipment. Go to the next slide, please, Adrian.
All right.
And so with that, you know, he was talking about good, better, and best. And I would say when we started with UE Systems back in last January, we were kind of in the good area, maybe even a little bit less than good. But with the implementation of the grease caddies, we actually now have 2 of them that we utilize. You know, we've gotten to that better stage where we're greasing things as they need to be greased. We're not putting too much grease in them. And so our long-term plan is to utilize ultrasound for all of our route-based lubrication, you know, all of those 538 points. Then use ultrasound to confirm mechanical issues. So we have, you know, from time to time, we'll have the production department tell us, hey, we've got this problem with this piece of equipment. Well, you know, a lot of times it's just somebody's feeling, but now we can confirm it. We can put some power in the production's hands, and so they can tell us exactly if they've got a problem with the bearing and stuff like that. And then I want to be able to equip our electricians with ultrasound. There's equipment out there, and I'm sure Adrian would love to tell you about it. But we've actually looked at it a little bit, and I think we're planning on making that move here in the near future where we can diagnose electrical problems with ultrasound. But that's neither here nor there since we're talking about lubrication, but that's kind of a long-term plan for us here at CMEX in Clinchfield. A lot of people ask me, this may be a question coming up that you guys are thinking in your mind, and I'll just go ahead and put it out there. You know, downtime costs, depending on what the equipment are here at my plant, can range from $1,000 an hour up to $10,000 an hour, depending on what piece of equipment it is. So when I look at the cost of what it takes to implement this, the cost of the equipment, the time it takes to get it started, you know, it was very minimal. It was the cost of maybe one of those downtime periods to get this thing all kicked off. And with even just a small amount of quick wins or success stories, it's able to pay for itself really quickly. So that was kind of some return on investment, if you might say. Adrian, I think that's all I got. Do you have the next slide?
Yeah, so James brought up a couple of good points. One, remote monitoring. That has become a big deal with ultrasound, a big application for us. And I guess that's one advantage of that UltraProbe 401, the digital grease caddy. We have remote access sensors that the standard lengths of cable are 12 foot, 25 feet, and 50 feet. So you go in, you mount the sensor, and then you bring that back out the other end of the cable, bring it back together to a junction box or just outside of the guard, the caged area. And those remote access sensors can plug directly into that UltraProbe 401. And we see that a lot in plants and facilities. You know, equipment that you used to have access to 10, 15 years ago, you no longer have access to. So, and due to caged off areas or guarding. So again, you can take those remote sensors, mount them to the equipment while it's safe to do so, and then bring those back together to a junction box or just outside the guarded area. And you can use that UltraProbe 401 digital grease caddy with those sensors. So let's see. So with that, the second point that I wanted to make that James brought up is, the fact, ultrasound is very versatile. Out of all the condition monitoring technologies, you can do your own research, but I think you'll find that ultrasound is the most versatile. So in most cases, the same instrument that you're using for compressed air leaks, you can also use for electrical inspection, or you can also use for steam traps or valve leak detection, condition-based lubrication. So you can use ultrasound for a multitude of applications. And again, if you're in the situation where you're not currently using any sort of condition monitoring tool, most people will start with ultrasound just simply because you can use it for so many different applications, and it's very easy to show the return on investment. Just as James did, if you look at the cost avoidance for the downtime, if you can find these bearings before they fail, or if you can prevent bearing failures due to lubrication problems, ultrasound is very good for that. So very easy to implement. If you have our equipment, if you're out there, if you need support, please feel free to reach out to us. That's what we're here for. If you have our equipment or anybody's equipment, we want you to be the best ultrasound user as possible. So with that, I'll turn it over to Maureen to see if we have any questions that have come through.
All right. Yes, we definitely had some folks starting to fire those off, so feel free if you've got some questions to type those into us. So here we'll start knocking these out. First one was for untrained technicians, which we have, how long would the training be to develop expertise in using ultrasound technology?
Yeah, so we have a tremendous amount of resources available. I don't know where the question came from, but in the U.S., for instance, we have a dedicated force of regional managers in the field who would be glad to come in for half a day to a day to help train you on the proper use of ultrasound for condition-based lubrication of bearings. We have this webinar is being recorded and archived on the website, but I would say time to implement. It's pretty typical that after that equipment orientation training that our regional managers will do, someone is confident enough to take the instrument out and begin to use it for bearing lubrication. Now, the hardest part is going to be just simply training yourself as to what things should and shouldn't sound like. I mean, you have to think the first piece of equipment that you walk out to and make contact with, you really don't know if it's good or bad or not unless it's just obviously bad. So initially it helps to do some comparisons. So if you can compare decibel level readings to identical equipment, same size bearings, same type equipment, same speeds, compare decibel levels, and you'd be surprised at how quick it is to kind of train yourself as to what things should and shouldn't sound like. So, time to implement, again, it really just depends on your manpower, how much time you have dedicated to this. And for those of you that are interested, we've put together an ultrasound program maturity matrix chart. And, when people are looking at implementing a condition monitoring tool, whether it be ultrasound or vibration or infrared, there's so much focus that's placed on the tool. Well, there's other things that need to be in place that are, I guess, where success is being made, or other metrics, if you will, that really need to be in use that will allow for the successful implementation and use of the tool. So again, we'll make that available. If you want that, shoot me an email and I can send that over to you. So I guess that's what I would say. There's a large number of resources out there that that we have available that can help for the successful implementation and use of ultrasound for condition monitoring, or really any application.
All right. Here's another one that came through. Can we use the accelerometer line for the grease caddy?
The accelerometer line for the grease caddy. I would think that they're probably asking where to make contact with the magnetic mount contact probe, maybe. Again, we want to be as close to the bearing as possible, so our first point of contact should be at the bearing housing or as close to the bearing as possible. Again, I mentioned the remote access sensors, so if you're any distance away from that equipment, you'd really want to use those remote access sensors, run those out to where you can access the end of that cable. It's just a BNC cable. Plug that directly into your ultra probe, 9,000, 10,000, 15,000, or 401 instrument. There is a docking plate, and it's basically just a little piece of metal that has a round indention to place the magnetic mount contact probe. That docking plate is mounted to just on the near the grease nozzle where the grease is coming out. So, if you can't get on the bearing, if you can't get close to the bearing, then you could use the docking plate. Again, it gives you a repeatable location to place the magnetic mount contact probe. But again, ideally, the closest point to the bearing is going to be where you want to make contact.
All right, and here's one. This guy says they're using the stethoscope contact module and finding they're picking up a lot of outside noise. They've got some fans and some other equipment that's making some background noise for them. Do you have a suggestion of how they can overcome this challenge so they can grease their bearings more accurately?
Yeah, so what I would recommend there, one would be frequency tuning. The recommended frequency setting, what we recommend at UE Systems is we recommend a frequency setting on your ultrasound instrument of 30 kilohertz. So first thing I would do there is begin to frequency tune, or if you have it set to 30 kilohertz, turn down the sensitivity. Again, the sensitivity on our instruments is kind of like a volume. Really, it's a gain. So the higher the sensitivity, the more power that's going to those receivers. So again, you want to lower that frequency or lower the sensitivity setting until you can begin to maybe block out some of that noise. You can also take the rubber focusing probe and slip that over your stethoscope module until the end is just sticking out of the end of the rubber focusing probe. That will help to shield out any competing noise. After you've done all of that, that's where I would start to look at frequency tuning. Just begin to turn down, start at 30, and then just kind of tune down, because really, we recommend 30 kilohertz, but we have some people that use 32 kilohertz. We have some that use 28 kilohertz. Whatever frequency setting you choose, just make sure that you always use that same frequency setting. But you could try to frequency tune, and I think that would probably help to block out some of that competing noise coming from those fans.
All right, great. And then as you were talking about the remote access sensors and the cables, this gentleman's wondering if you've got cables up to 50 feet, as you had mentioned, is there any degradation of the data the longer the cable is?
No, you can go safely as long as 100 feet. So I mentioned that the standard lengths of cable were 12, 25, and then 50. You can go as long as 100 feet very safely without any degradation in the decibel level or the signal.
All right, great. Ooh.
Adrian, I would suggest though, if you're going to go that long on your remote cable, be careful that your lube lines that run right along with it are not in the sun and messing up your quality of your grease.
Yeah, that's a great point. Along those same lines, I was in a facility. It's probably been 4 or 5 years ago now. What they would normally pump, the number of pumps of grease, I think was around 30 pumps of grease, and we were probably 8 to 10 feet away from the bearing. So again, we were using an extended grease line there. Well, they wanted to continue pumping grease until we saw a change in the decibel level. Again, what they normally would put, they would only put 30. That's what the PM called for. We got up to 54 pumps of grease, and then the decibel level just dropped completely off the scale. So again, had they been continuing on the time-based lubrication PMs, I don't know what the cause of that was. Maybe there was an air gap in the hose. Maybe there was some hardened grease that was being blocked there. But again, 54 pumps of grease before the decibel level fell back, and the PM called for 30.
All right, cool. And one last question. Who was it that won the national championship?
That would be the Clemson Tigers.
Oh, okay. All right. I figured you want one more chance to get that in there. All right. Well, thank you guys so much. And a couple folks had asked kind of similar question as far as, are we recording this? They must have hopped on a little after we started. So yes, we did record this, and I'll get this up on our website here later this afternoon. So if you want me to email you the link to the recording once we've got it up there, just shoot me an email. Or Adrian, or any of us, and we'll get it off to you. But yeah, so thanks, Adrian and James. Great information. Just a couple closing slides. Just want to make sure everybody knows if obviously lubrication is something of interest to you, we did just launch our online mechanical inspection and lubrication course. We're really excited about it. It's something you can take whenever, wherever. You take it at your own pace, at your own computer, but it really goes into a lot more detail about anything and everything to do with mechanical inspections and the lubrication process. So check that out if that's something that you'd like some more education on. And we've also got our compressed air survey online course. So we're really excited to have these extra training opportunities for folks who might not be able to travel all the time to get to a class that we're doing. So kind of use these as filler if you need to. Obviously, just another reminder, we are continuing on with our lubrication month. We've got another webinar coming up next week. We'll get an invite out for that tomorrow. So keep your eyes on your inbox for that. Hopefully you can join us again next week. And then just pointing out, we've got our UltraProbe users group on LinkedIn. It's a great place to take some of these conversations that we're having with the questions that are being asked, get some feedback from your peers, folks like James that are on there who can kind of give you real life answers to the questions that you've got. So take advantage of that community that we're building over there in LinkedIn. And if you're able to, we'd love for you to join us at our conferences coming up in May in wonderful, beautiful Clearwater Beach, Florida. It's our Ultrasound World and our Reliable Asset World conferences. Basically just 2 tracks of sessions. You got everything to do with ultrasound on one side, and then all kinds of really awesome speakers coming to talk on everything reliability and asset management. So we'd love to see you down there if you can make it. And with that, I'll leave our contact info up. Again, our website, uesystems.com, great resource, lots of information on there. So if you can't find something you're looking for, just holler at us and we'll get it for you. But with that, we'll let everybody go and enjoy the rest of their day. And thanks again to Adrian and James, and thank you all for joining us. Have a great afternoon, everybody.